Hey, my name is Filip, and this is a presentation on how to write a flaky test. Or rather, it's a presentation that is all about how to get rid of it. So what is test flakiness? Simply put, test flakiness happens when a test gives you inconsistent results. Essentially, when you're writing end-to-end tests, we are attempting to write a program that automates another program. A good test fits the app like two cogwheels fitting together. And when things start to grind, that's when test flakiness happens. Test flakiness has a ripple effect on the whole organization. It may result in lost confidence in test automation, more manual work because now you have to check flows manually, delivery slow down as you need to rerun a pipeline and your developers are waiting, lost test coverage because maybe you chose to ignore a test, execution slowdown, retrying, added debugging time, and most importantly, lost trust in QA process. I have consulted and collaborated with many companies, varying from e-commerce to fintech to SaaS. And I have seen these so-called strategies that help us live with the fact that our tests are flaky. For example, muting a test, quarantining a test, retrying a test, adding a longer timeout, reproducing a test locally, or deleting a test. Or, as I like to call them, shock, denial, anger, bargaining, depression, and acceptance. That's of course a joke. But there is one strategy that actually works, and that's fixing the damn problem. Or don't create it at all. Of course, this is easier said than done, and I'm not here to preach. The fact of the matter is that as the test automation grows, the problems with flaky tests grow with it. So how do you fix it? Well, generally, as our project scales, there are three axes on which the project grows. First axis is test coverage. Then on the other axis, we have test execution. And then the third axis, test performance. Flakiness can occur on any of these axes. On the x-axis, as the project grows, we deal with randomly occurring issues connected to DOM re-rendering and network-related issues. On the y-axis, as we run our tests in parallel, flakiness can come from stuff like bad test isolation or simply the infrastructure that we are testing on. And on the z-axis, we mostly deal with performance issues and flakiness connected to how tests execute. First off, let's talk about the first axis and the flakiness issues that arise as the test suite grows in a number of tests. And the most common issues come from DOM flakiness. Consider the following scenario. You want to select a card and assert its text. Notice how both of these elements contain the word bugs inside. So one is triage found bugs, the other one is search for critical bugs. Can you tell which card are we going to select when using this code? You might be guessing the first one with the text triage found bugs. And while that may be a good answer, it's actually not the most precise one. The correct answer is whichever card will load first. Consider if at time of the execution of these commands our app would look like this. We'd still select card elements, we'd still filter the first one and make our assertion. If we ignore what the application is doing, there's a high chance that our test is not going to do what we expect. This ties to the graphic I showed before, where the two cogwheels start to grind. So what's the solution? My recommendation would be to add a level of determinism to your test. One solution would be to add assertions to your tests that will serve as checkpoints, places where your app and your test are in complete sync. These will pretty much make sure that the test is not moving faster than the app or vice versa. The example checks number of elements, but this could be an assertion on loaders, no longer existing, API requests responding, element appearing, and so on. So let's now move on to the network flakiness. In this example, we have a very simple test with a to-do app. We want to test adding a new to-do item. So we visit the app, We check whether there are 0 items at the beginning, add a new to-do item, and check whether there is exactly 1. Along the test run, there are 2 moments when an API call is made. One is when we open the application under test, the other is when we create a to-do. And this test is flaky, because we don't really take network into account. So imagine this is a timeline of your test. We visit the application, and then we have an assertion that checks that there are no items in our list. So as the application opens, it calls this GET request. The problem occurs when the response takes a little longer, and our assertion happens way too early, before the response even comes back. We obviously might run into trouble if the response returns anything else than 0. An answer to this type of flakiness is obviously not ignoring the network layer. One of the solutions, as you can see here, is intercepting the set API and wait for the response to come back. But in this case, we should probably take it a level further. Since we want to create the very first item, we can mock the empty state, like we do here with an empty array. And this is a very effective way of eliminating network flakiness. There's obviously more, but the bottom line is that when it comes to network layer, it should not be ignored. So let's now talk about the second axis of scaling and the flakiness issues that arise from the way test is being executed. You probably already know that when you are writing a test, it should not have a side effect on any other test. In my experience as a consultant, I still see people trying to create tests that depend on each other. And this is flaky by design, because you're creating a situation where a test fails or is not even ran because of some outside factor. Normally, I would recommend splitting these tests into different specs. But you'd be right to point out that splitting these tests into their own spec files might also create problems once you decide to run your tests in parallel. You may have a test suite that creates a resource on one machine, a test that edits a resource on second machine, and then a test that deletes a resource on a third machine. Depending on how these tests run, you may encounter flakiness. Either you can delete an item before editing it, or try to delete a non-existing item, or create an item way too late. In any case, good luck debugging that. My number one advice would be that even if you don't run your test in parallel today, you should already start designing the test isolation. To do that, you can think about a common denominator for your test and make sure that it is separated on separate machines. So for example, if you are testing an e-commerce site, you should make sure that parallel processes don't share the same customer account. That way you can keep them isolated, and running them in parallel should not create any side effects. Another common problem when it comes to flakiness are infrastructure issues. It is not uncommon that running test automation happens on a staging server, and performance of that server is way too low compared to production. The funny thing is that even without parallelism, your test automation can become a load test. At one of the companies I have worked with, we have been using a testing account that would have thousands of resources on it. All of these API endpoints would contain way too much data and would strain the database. So simply opening an application and making frontend fetch those resources was something that made the backend work extra hard. And since our tests were nice and granular, which is usually a good thing, we would end up opening the application pretty often. We were pretty much DDoSing our staging server by opening that huge testing account tens or hundreds times a minute. One of the quick fix solutions I have used in the past, as many tests started failing, was to increase the default command timeout when a test failed. I wouldn't call this an ideal solution, but maybe you could call it pragmatic. Either way, the problem at hand, the huge testing account, needed to be solved, ideally by cleaning up the data. When designing a test suite, there's often a debate whether you should clean up your data after a test or before the test. While I generally lean to cleaning up before the test, if you really want to avoid flakiness, I'm pretty sure it should happen outside of testing. You can set up a cron job that will clean up the data created by tests. You can seed your database before. There are a bunch of solutions you can apply to avoid infrastructure problems and therefore test flakiness that lay outside of the tests themselves. The final axis is the individual test performance. So let's talk about dry principle. I have to say, I'm actually not a big fan of this principle. My friend David actually might have said it the best. Dry does not belong into tests. I could probably do a talk and a half on why I think you should probably use less abstraction than you already do in your test code. But I'll just say that overusing abstractions in your test code leads to harder debugging and maintenance. Test code should describe the app's behavior, and I have seen way too many instances of code being optimized for abstraction over being optimized to be maintainable. But I still think there's a grain of truth in the dry principle. If you want to avoid writing flaky tests, you should not be repeating yourself in test execution. In my example here, I'm using a custom command. The idea is pretty much the same. On the right side, you can see the abstraction being used. As we use it, we are repeatedly performing a login. And while our code is written with the dry principle in mind, the execution is repetitive and slow. And the more we use UI, the more we run into danger of flakiness. The way to solve this is by caching the browser state. In Cypress, you can do a snapshot of your browser after you have successfully logged in. And then you can load that snapshot. So as you can see on the test on the right, the UI login will only happen with the first test, and the rest of your test will instantly load the cached browser data and have you logged in. This is the best way to work with login in your test that will reduce execution time and will reduce flakiness. Finally, let's talk about test idling. This refers to any time the test is waiting. So you probably already know that you should avoid hard waiting as much as possible, but as we know, there are many instances where it seems like the waiting is inevitable. In any case, you should avoid explicit waiting whenever possible, and instead use timeouts. You can think of timeouts as the upper limits of a test failure, compared to explicit wait that just waits for a certain amount of seconds. That being said, you should avoid setting the limits too high, because that can make your whole test execution very slow, especially if you have multiple tests that have failed. Instead, you should make sure you set a granular timeout for a single test. So if you have a part of the application that is particularly slow, you should increase the timeout just for that. One of the most common areas that causes tests to be idle is the first page load. The easiest way to make sure that the page is loaded is by checking the DOM, and as the example on the left shows, wait for the loader element to disappear. A slightly more thorough way is to wait for the network calls. As the example on the right shows, you can use intercept to make sure that a certain API call happened, and then you can proceed with your test. There are also multiple ways of how it can be taken further. As this updated example now shows, you can wait for a whole array of API calls. Of course, you may not want to name all of the API calls one by one, especially if there are many of them. So you can choose an approach that is slightly more loose and wait for all the requests. Going back to the three axes of test automation, I think it is valuable to look at the type of flakiness you are dealing with. Whether it is sourced by rising number of tests, the way of how your tests are executed, or simply by the performance of automation script, flakiness should be something to be always watched for. Lastly, don't forget about the fact that you are trying to integrate two systems together, and that the test automation is, in a sense, a challenge of making sure that your test and your app play well together. My name is Filip Hric, and thank you for having me. You can follow me on Twitter or on LinkedIn, and I'll be happy to answer all of your questions. Happy testing, everyone!